Okay, so today we'll be looking at alkanols for year 12. During the course of this class, they want us to look at the state, the sources, and nomenclature of alkanols. They want us to look at the classification of alkanols, and they want us to explain the properties of alkanols. Okay, so we say that the general molecular formula for alkanols are CnH2n plus 1OH. Cn H2n plus 1 OH. See, the N is at the bottom, it's at the bottom. What do you call it? Subscript, yes. C subscript N H subscript 2n plus 1, then OH. So your CnH2n plus 1, as we know, is our alkyl group. So we're saying that our alkanols are ROH, okay? And then down to classification now, they are classified as monohydric, dihydric, and polyhydric. Examples of your monohydric are your ethanol, propanol, hexanol, um, one, two, is there one, two, 4, 5 dimethyl hexanol. Okay, now they have one OH. That is monohydric. Dihydric, they have two OH. Trihydric, they have three OH. Do you understand? Okay, so let's example of your dihydric now. We say ethane dihol. Okay, is an example of your dihydric. That's your glycine. Then propan 1,2,3 triol, your glycerol, is an example of what? Trihydric. Do you understand? Okay, that's one classification. So check out, if it has two OH, dihydric. If it has three OH, is what? Trihydric. Okay, so let's go. They can also be classified as primary, secondary, and tertiary. So how do you know if it is primary? Calm down. You go and look at the carbon that is bearing the OH, the carbon that is carrying the OH. You go and look at it very well. So you will now count how many hydrogens surrounding this carbon. If it is two hydrogens surrounding that carbon carrying the OH, don't forget it is primary. So it has two hydrogen, one alkyl group, one hydroxyl group. Do you understand? That is primary. Then for secondary, it will have two alkyl group, one hydrogen, one hydroxyl group. Then for tertiary, it will not have hydrogen at all. Everything is alkyl group. Don't forget to the carbon bearing the functional group. How we go? Okay. So that is for the classification. Now let's go to their laboratory preparation. Now for the laboratory preparation, in the laboratory you can prepare your ethanol. Let's take ethanol for example now. You can prepare your ethanol in the laboratory um, by hydrolyzing iodoethane with an alkaline. So when you hydrolyze iodoethane with an alkaline, or when you hydrolyze your ethyl ester with your alkaline, you get your ethanol. Or even when you reduce your ethanol, so reduction of ethanol can also give your ethanol in the laboratory. But commercially, how do we get our ethanol? Through process from your ethane and through fermentation. So from ethane now, how do we get? You know that ethane is a major product of petroleum. So once you get your ethane, have temperature of 80 degrees Celsius and 30 atmosphere. Temperature of what? 80 degrees Celsius and what? 30 atmosphere. Using H2SO4 as catalyst. Okay, all right. So let's go. So your ethane react with H2SO4 to give your ethyl hydrogen sulfate 6. That is C2H5HSO4. That is your ethyl hydrogen sulfate 6. No. Now this ethyl hydrogen sulfate 6 we now boil in water, or we now get hydrolyzed to your ethanol and your acid back. You understand? So your ethanol is C2H5OH. Is the second member of the series. The first member is methanol. And don't forget about methanol is our methylated spirit, and it's not good. You can't don't play with methylated spirit. I'm sure you know that. So that is that about ethane. So we said the process now. Ethene reacts with tetrahydrosulfate 6 to give your ethyl hydrogen tetrahydrosulfate 6, and your ethyl hydrogen tetrahydrosulfate 6 then hydrolyze to give your ethanol and tetrahydrosulfate 6. And the second process is through fermentation. So what do we say? What is fermentation? So literally we say that fermentation is the slow decomposition of large organic molecules like your starch now into smaller ones like your ethanol by microorganisms. Okay, so when microorganisms act on your starch to give your ethanol, it is what it is called fermentation. So what is the process involved? Now when you boil your cassava, an example of starch, when you boil your cassava, you get your starch. Now your starch is then acts upon um, like 50 degrees Celsius and 1 hour. Your starch is then acted upon by an enzyme diastase. So um, you have enzyme diastase acting on your starch to give what we call maltose. Okay, so another enzyme now acts on maltose. That enzyme is called maltase. Okay, so when maltase now acts on maltose, you now have glucose. Okay, so glucose is now then acted upon by another enzyme, zymase. So it is now your zymase that now gives your ethanol and carbon dioxide. So we take that again, diastase, maltase, and zymase. All right. And that is for starch. We also have for, okay, I should take that again. Okay, so let me slow down. Now, your cassava. From cassava, you get starch. You boil it to get starch. Then from starch, you get your maltose. Then from maltose, an enzyme acts on it to give you your maltose, which is your diastase. Then your maltose is acted upon by enzyme maltase. The enzyme maltase now, your maltose gives you glucose. Then another enzymes, the zymase, act on your glucose to give ethanol and carbon dioxide. Now it can also be prepared from your molasses, yes, your liquid syrup. But this time around, instead of maltose, what you have is your inverse. Instead of that diastase now, what you have is your invertase. Okay, so it's your invertase that actually get to do the job, and the invertase then you have fructose instead of glucose. Then it still breaks down to your ethanol and carbon for don't forget that your glucose and fructose have the same structure. Okay, so that is so let's we are good for the preparation. So let's go through um, their physical properties now. What are the physical properties now? Uh, they are colorless and they are volatile. Yes, they are volatile. They have high boiling point. Yes, their boiling point is 78 degrees Celsius. What is responsible for this boiling point is what we call the hydrogen bonding. The hydrogen bonding is responsible for that boiling point. And also, ethanol is soluble in water. And this hydrogen bonding is responsible for uh, this solubility. You know, we said you have OH. So the OH, you get the O in the OH can also link to another H. So that will now give water. So that makes them soluble in water. So we go through their chemical properties. Your ethanol can also undergo combustion reaction. Okay, they undergo combustion reaction to give your water and carbon dioxide. Okay, and they also react with sodium and potassium At room temperature, they react with sodium to give sodium methoxide. Okay, and this we can compare to you can compare this with the reaction of sodium and water. Don't forget. So when sodium reacts with water, remember it gives sodium hydroxide. But when ethanol reacts with sodium, we give what? Sodium methoxide. Okay, and sodium methoxide can still be hydrolyzed. So when you hydrolyze your sodium methoxide, you have your ethanol and you have your sodium hydroxide. Am I too fast? Okay, so let's take it slowly. Your sodium reacts with ethanol, or your ethanol reacts with sodium to give sodium ethoxide. You might be asked to compare these two. Reaction of ethanol with sodium and reaction of water with sodium. Okay, so when ethanol reacts with sodium, you have sodium ethoxide. When water reacts with sodium, don't forget the water is cold water, you have sodium hydroxide. Do you understand? And the gas in both is always hydrogen. Okay, it's always is hydrogen. We can also hydrolyze sodium hydroxide. Yes, further, we can also hydrolyze sodium hydroxide. So when we hydrolyze sodium hydroxide, we have ethanol and sodium hydroxide. Not sodium again. We have ethanol and what? Sodium hydroxide. Okay, so the same reaction is possible for potassium. Um, Number three, you said reaction with the chloride and phosphorus. So ethanol reacts vigorously with phosphorus 4 chloride. Okay, and when it reacts with phosphorus 4 chloride, it gives your chloroethane and your hydrogen chloride. Okay, so it gives chloroethane and your hydrogen chloride. But if it is reacting with um, phosphorus 3 chloride, it gives H3PO3 with your chloroethane. For phosphorus 5 chloride, okay, you have HCl. For phosphorus 3 chloride, you have H3PO3. Are we good? Please note that. You also have oxidation of ethanol. So when ethanol is oxidized, it gives ethanoic acid. So generally we are saying when alkanol is oxidized, it gives what? Alkanoic acid. So let's say for WAEC examination now, they can give you primary alcohol. So now your primary alcohol will oxidize partially to give alkanal. Primary alcohol oxidize partially to give alkanal, then it oxidizes again to give alkanoid. So in essence, we're saying that the complete oxidation of primary alcohol is alkanoid, and the partial oxidation of primary alcohol is alkanal. Okay, then the oxidation for secondary alcohol gives alkanone. No partial, no complete, just straight like that. So secondary gives alkanone, while tertiary no reaction. So they might give you probably for jam, those writing jam or those writing like maybe in the theory or bit. I don't know. Look at the compound. If it is primary, the oxidation if it is partial, it will be alkanal. Okay, and if it is complete, it will be what? Alkanoid. They can even give you in step, like they will write alkanol, they will now put something on top. O is oxid, that O stands for oxidation. So if they put one O, is partial. They put two open brackets O, you understand, two oxygen, it is complete. So you have alkanol, O1O, alkanal, alkanol, 2O, alkanoic. Or you can have alkanol, 1O, they will put question mark. They will now put another arrow, question mark. They'll put question mark on top of the arrow. They will now put question mark again on the product. Do you understand? So you should know that alkanol 1O will give alkanal. The second one, okay, on top of that question mark is O, then alkanoic. All right. Do you get that? Do you get it? Or do you want me to write it for you? If you want me to write it for you, please let me know. All right. Or if they want you to differentiate between the three, primary, secondary, and tertiary, you can also um, use that. Another famous chemical reaction is esterification. So esterification is when your alkanol reacts with your alkanoic to give your esters, that is your alkanoids and water. So what is esterification? Your alkanol reacts with alkanoic to give alkanoids and and water. Are we good? All right. Another reaction, chemical reaction, is that our alkanol can produce your ethene. We say we can get your ethanol from ethene. Okay, so we can do the reverse now. Very good. So uh, we can get our ethene from our alkanol. All right. So I'm sure we are good. So what are the uses of ethanol? Use of ethanol, we said they are important solvents like in your resins, in our soaps, in our dyes, in our um, varnishes, in our perfumes. Yes, they are important solvents, right? And we also said that they serve as a raw materials in the manufacture of some important things, important compound like your ethyl esters, your ethanol. And we said that they serve as an antifreeze in automobile radiator, okay, and that they can be used as fuel either by itself or when you mix them, right? And most importantly, I'm sure you know this one, they are what? Alcoholic beverages. Yes, your ethanol are alcoholic beverages. Okay, so we come to the end of our first class year 12. Please, if you have questions, please ask. Um, please ask. I'm just here for you, and I want you to know chemistry. It's not as difficult as you think. You don't want to go over your first topic, that is the first hydrocarbon, your alkane, and alkyne. Please let me also know. So we won't have to wait till that time to do it. For those of us preparing for WAEC or any external examination. All right. Thank you, and God bless you. See you next class. Bye.